Welcome to Miss Taylor's class notes, and today we're going to talk about dilations. So dilations are a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation and a scale factor of K. And when we dilate it, the ratio of the lengths of the corresponding sides of the are a ratio of the sides of the image and the pre-image. So another quick thing, if the scale factor is less than 1 or greater than 1, then our dilation is an enlargement, which means it gets bigger. If our scale factor is between 0 and 1, then our dilation is a reduction, which means it gets smaller. Dilations are not rigid motions. So these figures will not be congruent. These figures will instead be similar, and that's what our next notes are going to talk about, is how they're similar. So when we do our scale factor, and we're trying to find scale factor, we put our image over our pre-image. And that's where that little notation is our prime goes on top, or our new, let's write things, goes on top of the old. That's another way to think about it. So here I've got my original, my old, or my pre-image, which is going to go on bottom. And then here I've got my new, or my image, which is going to go on top. We always reduce our fractions. So 12 over 8, I can divide both by 4, which becomes 3 over 2. And because 3 over 2 is greater than 1, this is an enlargement. And so here we look, we've got our original, which is P, that's our pre-image, which is 30. We always put our original, our pre-image, or our old on bottom. And then our new image, which is marked by P prime, is 18. So again, we always reduce our fractions. We can divide all of these by 6, which is 3 over 5 is our scale factor. And then because that's less than 1, this is a reduction. And so again, that's our K, and that was our K for those. So we have two key dilation rules. We have our dilation around the origin, which is the super simple, super easy one. We just take our pre-image points and we multiply them by our scale factor. Again, K equals scale factor. If we instead rotate it or dilate it around a point, we have a much more complex equation, which we're going to get to later in a couple of examples. So now let's do some examples that are simple where our center is at 0. So again, it's always going to tell us where they're centered at. The origin is 0, 0. And so if the origin is 0, 0, things are super duper simple. So we have A, which is 2, 1, B is 4, 1, and C is 4, -1. Let me write the right number down. So it tells us that our scale factor is 2, so K equals 2. So what we're going to do to follow our rule is we're simply going to go 2 times 2 and 2 times 1, which gets us 4, 2 as a prime. So we're going to go 4 times 2, which is 8, 1 times 2, which is 2, that is B prime, and then we have 4 times 2 is 8, -1 times 2 is -2, and that is our C prime. So if we graph our original, let's put that first dot in the right spot. I still haven't put it in the right spot. Sorry, guys. So that's A, B, C. And then we enlarge it, and we get 4, 2. We get 1, 2, 3, 4, 8, 2, and 8, -2. And so this is A prime, B prime, C prime. So one thing to visually help you out and a way to kind of check to see if you're doing it right is you should be able to take your center and draw a straight line, and that straight line should go through both points, both the pre-image and the image point. So again, you should be able to draw that straight line from the center of dilation through both points. If you can do that, then you know you've done it correctly. So here our, oh no, go away. Our origin is centered, or is our center, so it's 0, 0. We've got our vertices, which is P is 6, comma, negative 6. Q is 4, negative 2. R is 6, 2. And our scale factor, or our K, is 1/2. Multiplying by 1/2 is the same as dividing by 2. So 6 over 2 is going to get me 3. Negative 6 over 2 is going to get me negative 3 for P prime. 4 divided by 2 is going to be 2, and then we get negative 1 for Q prime. Divide by 2, divide by 2. So R prime is going to be 6 divided by 2 is 3, 1. So let's graph our original. 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. That's P. 4 is 1, 2, 3, 4, 1, 2. Nope, it was the other way. And then 6, 2. So P, Q, R. Oh, let's draw some straight lines. And now we've got our new shape, which should be smaller. So we've got 1, 2, 3, 1, 2, 3. It's P prime. We've got 2, negative 1, which is Q prime. And we've got 3, 1, which is R prime. And again, we can check it real quick by drawing a straight line that should go through both points. And so, yep, we did it correctly. All right, so these get a little bit more complicated because this is with our complicated rule. So I'm going to real quick write our rule up here. So x comma y is transformed into k times x minus a plus a, comma, k times y minus b plus b. So our a and b are going to be the center. Our x and y are going to be the points. So what I'm going to do initially is I'm just going to kind of set it up, our general problem based on our rule. So this one is going to be centered at 1, 2. So if it's centered at 1, 2, my rule is going to be x, y. Our scale factor is 1/3, so it's going to be 1/3 times whatever our x point is minus a is going to be our where it's centered at, plus 1, 1/3 y minus 2 plus 2. And once we get those numbers in there, it gets a lot simpler. It gets a lot easier. So now I'm going to take k, which is negative 2, 8, and we're going to go 1/3 minus 2 minus 1 plus 1, comma, 1/3. We're going to get our y, which is 8, minus 2 plus 2. And again, this is for k. So I do parentheses first. So it's going to be 1/3. A negative 2 minus 1 is negative 3 plus 1. 1/3. 8 minus 2 is 6 plus 2. So I can cancel out my 3's because they're diagonals. I'm left with a negative 1 plus 1, comma. I can cancel out that. This becomes a 2, so I get 2 plus 2. And then finally, a negative 1 plus 1 is 0, and 2 plus 2 is 4. So this is k prime. And so now we can move on to L, which is 1, 8. And again, I'm going to take what I have right here, and I'm just going to plug in L's numbers. So 1/3, our x for L is 1. Then we put -2 plus 1. Then we do 1/3. Our y is 8 minus 2 plus 2. And this is where I kind of start doing a few shortcuts. So because I noticed that this right here is the same math as this right here, I know that's going to end up being 4. So I don't need to really do that math again because I've got the same point and the same information already. So now I can just kind of focus on this. 1/3, 1 minus 2 is -1 plus 1. So it's going to be a -1/3 plus 1. Hold on. Something in my math went a little... Oh, it's supposed to be 1. I wrote down the wrong number. I knew something went wonky because that did not match up what I'd done earlier. This one's -1. So 1 minus 1 is 0. So we have 1/3 times 0, which means those cancel, which leaves me 1. So L prime is 1, 4. So now we've got one more. We've got M. We can't cheat with M because M has 2 completely different numbers than K and L. So we're actually going to have to do this math for all of it. So 1/3, our x for M is 4. Nope. And then we need to do 4 minus 1 plus 1. 1/3, our y for M is 5 minus 2 plus 2. So again, we do parentheses first. 4 minus 1 is 3 plus 1. 1/3, 5 minus 2 is 3 plus 2. So again, I multiply first, so those cancel, so I'm left with 1 plus 1. Those cancel as well, so I'm left with 1 plus 2, which gets me 2, 3 for M prime. So let's graph this all just to make sure that we did it right. So K is -2, 1, 2, 3, 4, 5, 6, 7, 8. Then we have 1, 8. And then we have 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. And so that's our triangle there. That's K, L, and M. Our center of dilation is at 1, 2. And then our new figure, K prime is 0, 1, 2, 3, 4. L prime is 1, 4. And then M is 2, 1, 2, 1, 2, 3. So it's definitely a reduction. It's definitely smaller. And then let's just kind of perform our last test to make sure that if we draw a straight line, it goes through both points. All right, so we are in good shape there. All right, so I'm going to help set this problem up, and then I want you to do the math on your own. So if we're using our formula up here, so K is 1/2. We don't know what our x is because that's where we're going to get our point, but it's centered at 1, 1. So it's going to be -1 plus 1, 1/2 y minus 1 plus 1. So I want you to do this one on your own, and I want you to check with the class notes. These are both centered at 0, 0, so these are our simpler, our easy ones. What's slightly different on these is that because it's a negative scale factor, it's going to put it on the opposite side of the graph. Actually, nah, let me do this first one with you guys. I'm remembering now that these can be a little funky. So let's graph FGH, -1, 2, 3, 4, 1, 2, 1, 2, 1, 2, 3, 4, -2, ooh, I did not put that. Oh, yeah. So this is FGH. We have a scale factor of a -1/2, so that means I'm going to divide -4 and -2 by a -2, which means I'm going to get a +2, +1 for F prime. +2, +1. And then we've got -2 divided by -2, 4 divided by -2. So we get a +1 and a -2 for G prime. So +1, -2, so that's F prime, G prime. And then H prime is -2 divided by -2, -2 divided by -2. So that's going to become a +1, 1, which is H prime. And our center of dilation is the origin. So I should be able to connect both G's in the center of origin, should be able to connect both H's in the center of origin, and I should be able to connect both F's in the center of the origin. So I want you to do this one on your own, and then we're going to just real quick make sure we understand how to do scale factor. I'm sorry, I know this is a long video, but there's a lot going on in this. So we've already kind of worked on this and already kind of talked about it. C prime over, or prime over the image, and new over the original. So you're making photo stickers. Your original photo is 4 inches by 4 inches. You're creating your image on the stickers. It's going to be 1.1 by 1.1. So I need the new 1.1 over the old, which is 4. And then we're going to do a little bit of math with this. So I can turn 1.1 into 11 over 10 divided by 4. So remember, when we divide our fractions, we flip them. So it's going to be 1/4. And so we end up with 1 times 11 is 11. 10 over 4 is 40. And so our scale factor is 11 over 40. So you're using a magnifying glass that shows the objects of the image that is 6 times the object's actual size. So to determine the length of the image of the magnifying glass. So it's 6 over 1 because the new image or the new picture is 6 over 1. So the image through the magnifying glass. So the regular ant, or yeah, that's a spider, is 1.5. And we're looking for that number there. So here, we're going to cross multiply and divide. So 1.5 times 6. So 6 times 5 is 30. 6 times 1 is 6. So 6, 7, 8, 9. So 9 centimeters is how big the spider is going to look through the magnifying glass. So I want you to do these last two on your own to find the correct number and check with the class notes.